All right, let's go ahead and review everything that we've learned in our polynomial unit. You should have this review from the Wednesday folder yesterday. So let's go ahead and get started. The first section was just factoring. So if I'm going to factor x squared plus 36, that is your sum of squares. Because it's plus, you can't do x plus 6, x minus 6, so you have to include that I. As x plus 6i, x minus 6i. Cool? But now x squared minus 25, since this one is the negative, you can do x plus 5, x minus 5. Okay, now going to some trinomials where the leading coefficient's not 1. This is where you taught me how to do whatever process you use in your projects that you submitted. So the first step is always take out a GCF if there is one. So every single one of these terms has a common factor of 6. So I would factor out a 6. I'm left with 6x squared minus 7x plus 2. And then this section is what you're using, whether you did box method or the star method or the factor by grouping. Whatever you use, that's what you're using here. What I like to do is put 6x in the beginning of both, and then multiply a and c, so 12. So what multiplies to 12 but adds to negative 7? That would be negative 4 and negative 3. They both need to be negative to get positive 12 when multiplied, and both need to be negative to get negative 7 when they're added. Now the final step to this process that I use is you have to simplify. So both of these can be divided by 2, both of these can be divided by 3. So your final answer, bring down your 6. This will be 3x minus 2. This will be 2x minus 1. Okay, so I'm going to use the same process for this one. There is no common factor, so I'll go ahead and get started by putting 4x as the leading term in both parentheses. So 4 times negative 10, that's negative 40. So it multiplies to negative 40, but adds to positive 3. That'll be 8 and 5. I need a positive 3, so plus 8 minus 5. Okay, both of these are divisible by 2, and then this cannot be simplified. So I'm left with 2x plus 4 and 4x minus 5. Why do I feel like that's not right? Oh, these can be divisible by 4. Psych, guys, LOL, gotcha. There's a greater factor, 4, so this is just x plus 2. Okay, there we go. So it's always good to FOIL. A lot of y'all did that in y'all's projects, which was awesome. FOIL at the end to make sure you get what you're equal to, especially on your test. Check your work, y'all. Don't just write the answer and say you're good to go. All right, last one is 4 terms. We're going to be factoring by grouping. So I'm going to group the first 2 and the last 2 and take out the GCF of each. The GCF of the first 2 is 6x squared. If I take 6x squared out of this term, I'm left with just a 4x. Now, a lot of you on your projects, y'all just left it as 4x because you completely took out the 6x squared. However, when you take it out, you still have to include the minus 1. Because I need to be able to distribute this back to get this initial term. All right, so now I'm going to factor out a positive 2. So 4x minus 1 again. Take your 2 numbers that you factored out, and then what's left? Cool, cool. Okay, the next one gives us a polynomial and gives us 2 factors, and it wants us to factor the rest. So if I need to take out x plus 2 and take out x minus 3, I'm going to do some synthetic division. So first, I'm going to do the x plus 2. If I do x plus 2 with synthetic division, I'm going to use a negative 2. So write out my coefficients. Bring down the 1. Times negative 2 is negative 2. That's 0. 0 times this is 0, so I'm left with negative 19 times negative 2 is positive 38. Add these to get 30 times negative 2 is negative 60. So we knew it was going to be 0 because it already told us it was a factor. So I've already factored out x plus 2. Now I have to factor out x minus 3. So now I'm going to use this, what's left over here, and take out a positive 3. So bring down the 1. 1 times 3 is 3. 3 times 3 is 9. That's negative 10. There's our negative 30. Okay, so if I'm going to completely factor, I've already factored out an x plus 2, an x minus 3, and now what's left will be x squared plus 3x minus 10. So now this is not completely factored because I can factor this last piece further. So I'll rewrite the first two again. This last one's leading coefficient is 1, so that's pretty easy. You just have x and x, and you have to decide what multiplies to negative 10 but adds to positive 3. That's 5 and 2. To get positive 3, you need 5 minus 2. And there is f of x factored completely. Yay! Okay, now on to our graphing. So we have to take all the roots, the multiplicities, figure out the y-intercept, graph it, all the things. So looking at this equation right now, I don't see all the roots because it's not fully factored. So we need to fully factor her. Negative x cubed is fine. This middle term, though, can be factored further. And then we have x minus 6. All right, so I have x and x. What multiplies to positive 6 but adds to negative 7? That's negative 6 and negative 1. Well, before I continue, I notice I have two x minus 6's. So I'm going to rewrite that as one term squared. So I'll have x minus 6 squared and then x minus 1. So I don't have to write this one because it's included in the squared. So I have 3 x's. I'm going to have 3 roots. When you have your x by itself, that root is 0. X minus 6 will be positive 6. X minus 1 will be positive 1. Now for each of their multiplicities, remember we find their multiplicity by looking at their exponent. So the root for 0's exponent was 3. 6's exponent was 2. 1's exponent, there's nothing there, so it's just 1. Now the multiplicity tells us to bounce, wiggle, go through at each of those roots. So when I go to my graph, I'm going to plot those 3 roots, 0, 1, 6. And before I can graph, I have to figure out where my arrows go. So I have to figure out if this is a positive, negative, even, or odd. So I'm going to add up these multiplicities, 3 plus 2 plus 1, to get 6. 6 is an even number, so this will be an even graph. But it's going to be a negative even because I have a negative sign in the front. So I'll have a negative even. Going back to your notes, you know a negative even graph starts down and ends down. Okay, so I'm gonna go to 0 first. 0's multiplicity is 3, that's a wiggle. 1's multiplicity is 1, so I'm gonna go through. 6's multiplicity is 2, so I'm going to bounce. There's our graph. The last thing I have to determine is my y-intercept. The y-intercept here is already drawn. We don't have to solve anything. It's just 0, 0. All right, let's do another one. Again, it's not fully factored, so let's factor this first piece. What multiplies to 6 adds to 5. That's 3 and 2, but I still have an x plus 3. So same as before, I have 2 x plus 3's, so I'm going to rewrite them as x plus 3 squared, and then the x plus 2. I have 2 x's, so I'm going to have 2 roots. The first one is negative 3, second one negative 2. Their multiplicities come from their exponents, so that'll be 2 and 1. Remember, 2 means bounce, 1 means go through. Let's figure out if it's positive, negative, even, or odd. My equation is positive. 2 plus 1 is 3, so that's an odd number. So going to your notes, figure out what a positive odd looks like. Our roots, -3, -2. Positive odd starts down and ends up. -3's multiplicity is 2, so I'm going to bounce. -2's multiplicity is 1, so I'm going to turn around and go through. Okay, there's our graph. The last thing we have to figure out is this y-intercept here, because it's not 0, 0 like last time. Remember from Algebra 1, to find a y-intercept, you just plug in 0 to your x values. So it'd be 0 plus 3 squared and 0 plus 2. Okay, well 0 plus 3 squared is just 3 squared. So that'll give us 9. And then 0 plus 2 is just 2. So 9 times 2 is 18. My y-intercept, 0, 18. Okay, I'm gonna go ahead and do the next page in another video just so it's easier for me to upload. All right, see you in a second.